Welcome to Srividya Academy for Special Education Learning Made Easy. We will solve an indefinite integral in this video. It's given that integral dx by 2x plus 3 whole to the power of 1 by 3 plus 2x plus 3 whole to the power of 1 by 2, which we need to evaluate. To solve such typical problem, we have a technique here, that is, if I is equal to integral dx by ax plus b whole to the power of 1 by m plus ax plus b whole to the power of 1 by n, then we can substitute ax plus b is equal to t to the power of 1 by p, where p is LCM of m and n. So the given integral can be compared with this ax plus b whole to the power of 1 by m plus ax plus b whole to the power of 1 by n in the denominator. Here a is 2 and b is 3 here, and m is 3 and n is 2 here. That is, when we compare the given integral with this I equals dx by ax plus b whole to the power of 1 by m plus ax plus b whole to the power of 1 by n, we have m is equal to 3 and n is equal to 2, and LCM of 3 and 2 is 6. Therefore, I have to substitute 2x plus 3 is equal to t to the power of 6, where 6 is the LCM of 3 and 2. We will differentiate this with respect to x. Therefore, on the right hand side we get 6t to the power of 5 into dt by dx. On the left hand side here we have 2, derivative of x is 1 and derivative of 3 is 0. When we take this dx to left hand side, that is to the numerator of the left hand side, we get 2 dx is equal to 6t to the power of 5 into dt. That implies dx is equal to 3t to the power of 5 dt, that is, we are dividing by 2. Now in the given integral, in place of dx I can substitute 3t to the power of 5 dt, and in place of 2x plus 3 I can substitute t to the power of 6. Here also, that is, at 2x plus 3 I can write t to the power of 6. Therefore, the given integral reduces to integral 3t to the power of 5 dt in place of dx, and in the denominator t to the power of 6 whole to the power of 1 by 3 plus t to the power of 6 whole to the power of 1 by 2. That is, in place of 2x plus 3 we put t to the power of 6. Now numerator is 3t to the power of 5 dt as it is in the next step, and in the denominator we have t square plus t cube, that is 3 2s are 6 here and 2 3s are 6, that is, we got t square plus t to the power of 3. We can take t square common, so we get t square into 1 plus t in the denominator. Now we can take this t square to numerator, so that we are left with t cube, that is t to the power of 5 into t to the power of minus 2, which is t to the power of 3. 3 is constant, we are keeping it outside, so I is reduced to 3 into t to the power of 3 dt by 1 plus t. So now we can observe that this is an improper integral. So to get the solution, let us divide t cube by 1 plus t first. So when we divide t cube here, so that is t cube divided by 1 plus t. So to eliminate t cube, we will multiply by t square, that is, let us multiply 1 plus t by t square. Therefore t square into t is t cube, t square into 1 is t square here. On subtraction, t cube is eliminated and we are left with minus t square as remainder. Next, to eliminate this minus t square, let us multiply 1 plus t by minus t. Therefore, minus t into t is minus t square here, and minus t into 1 is minus t here. Next, on subtraction, this t square is eliminated and we are left with plus t. To eliminate plus t, let me multiply this 1 plus t by 1. Therefore, 1 into 1 plus t is here 1 plus t. So on subtraction, t is eliminated and we are left with minus 1. Therefore, t cube divided by 1 plus t is nothing but t square minus t plus 1 minus 1 divided by 1 plus t here. That is t cube by 1 plus t is t square minus t plus 1 minus 1 divided by 1 plus t in the next step. So that is we got t cube by 1 plus t as t square minus t plus 1 minus 1 by 1 plus t. Now I was, that is given integral was reduced to 3 into integral t cube by 1 plus t dt. Now in place of t cube by 1 plus t, we are writing t square minus t plus 1 minus 1 over 1 plus t into dt. These three constant as it is. Now we can integrate this with respect to t. Therefore 3 is constant as it is here. Integral t square is t cube by 3. Integral t is t square by 2. This minus sign is here. And integral 1 dt is t minus logarithm of 1 plus t. That is numerator is exactly the derivative of the denominator. Therefore dt by 1 plus t is log of 1 plus t plus constant of integration. Now let us substitute 2x plus 3 for t to get the answer as a function of x. Therefore I is equal to 3 into, here instead of t cube we have 2x plus 3 whole cube. Instead of t square here we have 2x plus 3 whole square. Instead of t here we have 2x plus 3, and log of, instead of t here 2x plus 3 plus 1 means I have 2x plus 4 plus c.